Hello and welcome back to another Walking Talking Mock. This is a further maths paper. It's 2014 and this is the paper 2, so calculator paper. Okay, question 1. The graph of y equals f of x for the full domain is shown. The graph consists of a quadratic curve and a straight line. Complete the boxes to describe f of x. Okay, so between -2 and 2, what have we got? -2 and 2, this is a quadratic. Okay, so it's something like x squared. 1 squared is 1, 2 squared is 4. Okay, so it is just x squared. It's just x squared. And between 2 and something, well, the something is 5, I can see that. Between 2 and 5, it's just a horizontal line, and the y-coordinate is 4, so it's just equal to 4 all the way through. I feel like I've done this paper before. Do you think I have? Maybe, but I don't think I've done a video on it, so okay. The equation of line AB is y equals 12 minus 2x. The area of triangle OCA is 24 square units. Work out the coordinates of C. Okay. Interesting. Let me work out the coordinates of A and B first, because right now, this is my thought process, right? I've got absolutely no idea how to do this question. But I'm going to do what I know how to do, and I know that if I have an equation, I can work out the intercepts, because I know how to do that. So at this point, I'm not even thinking about C, because I've got no idea. And I'm not even thinking about the area being 24, because I've got no idea. So I'm just going to do what I can do. It's a good strategy. So let's start with B. B is going to be 12 because it's the y-intercept. So that's going to be 0, 12. By the way, as you can see, I'm using a different pen from normal because I'm just really sick of writing in felt tip pen. It just annoys me, especially in further maths when you have to write kind of small to fit everything in. So please let me know if this pen isn't readable enough for you, and I will grudgingly change back. Okay, A then is where y is 0. So if 0 was y here, if I had 12 minus 2x equals 0, and I solved that, I would have 12 equals 2x, so 6 equals x. So that is 6, 0. Okay. The area of triangle OCA. Okay, so I know that the base of the triangle is 6. Area of triangle is half base times height. Okay, therefore the height must be 8, because 8 times 6 is 48, and half of 48 is 24. Okay, that must mean that the y-coordinate of C is 8, because that's the height. Okay, what about the x-coordinate? How about this? The area of the whole triangle OBA, the area of OBA is going to be half base times height. Height is 12. So that's 36. OCA is 24, so OBC would be 12. Okay, and if the area of that's 12, and the base of it is 12, then the height of it is going to have to be 2, because then 2 times 12 halved makes 12. Okay. So if that height is 2, then that means the x-coordinate of C is going to be 2. So C is 2, 8. I like how I didn't use any of the actual answer space to answer that. I don't like doing maths on lines. I don't know why. Oops. Question 3. RS and T are on the circumference of a circle, centre O. Give a reason why angle OTS, that's that one. Give a reason why angle OTS equals X. Okay, so it's the same as that. Well, that's because it's an isosceles triangle, isn't it? Because this length and this length are both radii, so it's isosceles. Okay. So how shall I write this? OT equals OS, both radii. Therefore, OTS is isosceles and base angles in an isosceles triangle are equal. Okay, work out the value of x. Oh, see, they've given you a clue by making that part A. So you know that that's x. And you also know that 30 plus x is going to be half of 5x, because angle at the centre is twice the angle at the circumference. It doesn't say give reasons, so I'm not going to write that down. I will say that 5x is twice the angle at the circumference. So now I just need to solve that. So x is 20. Expand x squared, x minus 2. Okay, easy. X cubed minus 2x squared. A curve, 2 marks for that. Wow. A curve has equation that. Work out the gradient of the curve at the point 39. See, and again, part A gives you a hint. If part A wasn't there, and it just said this, work out the gradient, you might have differentiated this, like, badly. You might have said, oh, this is 2x, and this is 1, and, you end up with the wrong answer, because you have to expand the brackets first. You absolutely have to expand brackets first. You can't do it without expanding the brackets first. But it's nice that part A, it was there to just kind of, like, nudge you towards that. Anyway. So let's differentiate. I'm going to differentiate the expanded version. So 3x squared minus 4x. We want to find the gradient when x is 3. So we're going to sub x is 3 into that. I'm going to get 3 lots of 3 squared minus 4 lots of 3, which is 27, take away 12, which is 15. Line L is the tangent to the curve, same curve, at the point 39. Work out the equation of L give your answer in the form y equals mx plus c. And again, part C, you can use your answer to part B to help you. In the Further Maths textbook, this part C would be like a question by itself. It wouldn't have the A and the B, and there's quite a lot of steps to it if you do it that way, and it's kind of daunting. But this has broken it up. So you already know the gradient at this point is 15, so you already know it's y equals 15x plus c. And then you just have to substitute in a point, which is going to be 3, 9, to work out the c. So c is minus 36. So y equals 15x minus 36. Question 5. Solve this algebraic fraction. Okay, I'm going to times both sides by 10. Because if I times both sides by 10, it's going to get rid of the 2 and it's going to get rid of the 5. I don't need to write this, but I'm going to write it just to show you, really. Okay, so if I times this fraction here by 10, I'm going to end up dividing it by 2, so really I'm just timesing it by 5, because the 2 cancels out with the 2 in the 10. So I'm really just timesing the top by 5. So that's 20c plus 15. And the 2 on the bottom is cancelled. And then this fraction, when I times it by 10, the 5 is going to cancel, so I'm just timesing by 2. And I also have to times the right-hand side by 10, just to make it fair and balanced. Okay, so that's 22c minus 1 equals 10. 22c equals 11. C equals a half. I feel like when the answer's a half, you've probably done it right. Do you know what I mean? 2 circles, each with centre O, are shown. O being the origin. The equations of the circles are that and that. Okay, so straight away I know that the radius of that is going to be the square root of 289, which is 17. And the radius of this is the square root of 121, which is 11. Work out the perimeter of the shaded section ABCD. The perimeter of that, interesting, okay. Right, well the radius of A is, not the radius of A, the radius is 11, right, the smaller one is 11. That means A is going to be 11. Well, the x-coordinate of A is 11. And the x-coordinate of B is 17. So I know that that distance there is 6. And it will be the same up here as well. Okay, so I've got part of the perimeter. I need the arc bit, so let's colour code this. So that arc there, that orange bit, is going to be pi times diameter. What's the diameter of that? 22. But it's only a quarter of the circle, so I'm going to divide it by 4. So that is, well, let's just write it as 11 pi over 2. And then we've got this bit. And that bit is going to be pi times diameter, so pi times 34 divided by 4, because it's only a quarter of the circle. So I'll just write that as 17 pi over 2. Okay, so the total perimeter will be 11 pi over 2 plus 17 pi over 2 plus 12. The 12 is the straight bits there. So if I add those together, I'm going to get 28 pi over 2 plus 12. So that's 14 pi plus 12. It doesn't say to give it to so many decimal places or anything, so I'd be tempted to leave it as that, but actually it is a perimeter, and perimeter is a measurement, so measurements you should really give as a decimal. I'm just going to type that in my calculator. 55.98 to 4 significant figures. And I should put centimetres. Actually, it doesn't say centimetres, so I'll just write units. When you don't know what the units are, you're supposed to just write units. Okay. Number 7. Simplify. Square root of x to the 5 times x to the 9. So let's start by simplifying that into 1 power. When you times numbers, then you add the powers, so that's x to the 14. And when you square root, you're halving the power, so it's x to the power of 7. Because x to the power of 7 times x to the power of 7 would make x to the power of 14. Solve y to the minus 3 equals 125. Okay. So to get rid of the minus, I need to do 1 over the reciprocal. And to get rid of the cubed, I need to cube root. So y is a fifth. Wait, we have a calculator for this as well. That makes it really easy. I suppose it doesn't make it that much easier. Right, we've got a matrix here. M equals minus 2, 3, minus 1, 1. Show that m cubed equals, right, that's the letter I, in case you were wondering, because it's a bad font, to be honest, because that could be like a lowercase l, or it could be a number 1. But no, it's a capital I, and it's bold. The boldness shows you that it's a vector or a matrix, because vectors and matrices are are bold. And I, something you're supposed to know, I, as a matrix, is the identity matrix, and it is 1, 0, 0, 1. It's called the identity matrix. And it's called the identity matrix because if you apply that matrix to a vector or to a pair of coordinates, it doesn't move the coordinates. It doesn't change the coordinates at all. It just gives you the same answer as before. It's like when if you multiply something by 1, it doesn't change. Well, when you multiply something by the identity matrix, it also doesn't change. But it as a matrix. Okay, so m cubed. Right, so m squared is m times m. So let's work out m times m. So I'm going to write them next to each other. Okay, and I'm going to do minus 2 times minus 2 is 4. Minus 1 times 3 is minus 3. I should have probably left more space. So that's 4 minus 3, which is 1. Okay, then I'm going to do minus 2 times minus 2 is 2. Minus 1 times 1 is minus 1. Oh, I was worried for a moment because that doesn't give a 0, but then I remembered this is m squared and we're trying to do m cubed afterwards, so That's okay. 3 times minus 2 is minus 6. 1 times 3 is 3. 3 times minus 1 is minus 3. 1 times 1 is 1, which is minus 2. Okay, so that's m squared. Then m cubed is going to be m times m squared. Minus 2 times 1 is minus 2. And minus 1 times minus 3 is plus 3. Minus 2 times 1 is minus 2. Minus 1 times minus 2 is plus 2. That makes 0. 3 times 1 is 3. 1 times minus 3 is minus 3, which makes 0. 3 times 1 is 3. 1 times minus 2 is minus 2, which makes 1, which equals that, which equals the identity. Okay, and that will do for part 1, and I will see you later for part 2.